today. And as Roberta said, I'm relatively new as director of Large Molecular Telescope starting in June. And so I'm very excited to be in this role. And I've had some connections with LBT that go back a ways. On the other hand, I'm still learning a lot. I know many people in this audience have long associations and deep associations with this facility. So please excuse me for gaps in my knowledge or ill-informed statements I might make. But it is very exciting to be part of this organization, and I really appreciate the opportunity to connect with you all who have such an important role with this telescope. So let me say just a few more words about my background. So I got my start in astronomy as a graduate student doing a PhD at UC Berkeley. And the picture there shows the telescope I used for a large part of my thesis, the 3-meter Lick Observatory. And I'm sort of dating myself because this was before the Keck telescope was available. So that was the biggest telescope I have access to. From there, I went to my first postdoc at Ohio State. And when I was at Ohio State, there was a lot of excitement about this project they were getting involved with called the Columbus Project, right? And those of you with long memories know that was the original name for what became LBT. And this shows the cover of a report, a feasibility study for what was being called the Columbus Project. I went from there to Stewart Observatory, where I had a Hubble Fellowship. And again, there was a lot of discussion about this very exciting project, which by then was being called the Large Molecular Telescope. And it was around the time I left that construction started on the facility. So I've had connections that go back a long ways, and it's really exciting to come back after these years and see how that concept has achieved reality. I have a picture of the Hubble Space Telescope here because that was also an important part of my research. It funded this important postdoc I had, and I've remained involved with it in various ways over the years. So after leaving Stewart, I became a faculty member at Ohio University, it's separate from Ohio State, about 100 kilometers away. And there I helped start a new astrophysics group in a sizable physics department, and had some success. That's a picture of our group after some years after we grew that. And then my career took a path I never would have predicted. I ended up finding myself in various leadership and administrative roles as a department chair, and later as a dean, and then as vice president for research. And that was very interesting, but I'm really happy that I can bring that experience in management and leadership roles back to my first passion, which is a focus on astronomy with this incredible facility. So my research has been mostly in the field of active galaxies and studying galaxy nuclei, and also various sources of nebular astrophysics sources in interstellar medium, using multi-wavelength spectroscopy as well as imaging. And I've used a number of different facilities. And I also want to do, besides introducing myself, I want to introduce another person who's traveling with me on this trip, which is Mark Smithwright. He is our head of engineering at the observatory. He's been with us about 1.5 years, and brings very deep expertise related to adaptive optics. He had several companies that he started in the optics industry, and it's really useful what he's brought there. And so we've got some ambitious things we're trying to do to make the telescope more successful, and I think he's really helping us move in that direction. Okay, so the title of my presentation was envisioning the LBT as a discovery machine, and I want to talk some about some recent discoveries that have come out of this telescope that I think are exciting and illustrate its capabilities. So a recent science highlight is from the Pepsi Exoplanet Transit Survey. And this has people involved across the telescope consortium, Ohio State, ENAP, MPIA, AIP, Arizona, and so on. And this is for transit studies of planets planets undergoing transits. And so this particular study is for KELT 20b. It's an ultra-hot Jupiter. The spectra acquired with Pepsi is shown here in black, and after absorption For correction for telluric absorption, you get the red spectrum. And a noteworthy thing there is that you see emission lines. And that's telling you that in this hot Jupiter, there's a temperature inversion. And in order to get a temperature inversion, you have to have an absorber in the atmosphere. And the question is, what is that, right? So there's an important question here about the structure and physics of this exoplanet atmosphere. So it's pretty hot, and that rules out a lot of molecules that wouldn't be able to survive in that environment. And what these observations allow us to do is to place sensitive limits on some of the remaining molecular candidates. They were not detected, but there's sensitive upper limits to their presence, and that's going to point the direction to putting together a model, perhaps relying on atomic absorbers to create this temperature inversion. The second result that came out recently with important contributions from ENAF as well as other partners is this study deep, large molecular camera R-band observations of the Goods North field. And the science question here is there is a disparity between broad measures of extragalactic optical background light and what you would predict just from counts of galaxies. There's some other contribution to the light based on a simple scaling. And the question is, where is that light? And so the Hubble Space Telescope observations, of course, are fantastic for high resolution detection of galaxies, but it has limited sensitivity for low surface brightness extended emission that might be associated with these sources. And this is where LBT has some leverage. And so these observations allow you to probe more extended low surface brightness components of these galaxies, which might include tidal features if there's more interactions in the earlier universe between these galaxies. So this is used a bunch of measurements with Sloan R-band, and then subsequent analysis. You can see regions of low surface brightness that were detected, but even if you add up that light, you get more. But there's still a disagreement between what you measure in this way associated with galaxies that you detect and these broader measures of extragalactic background light, which require some explanation. So the mystery is not completely solved, but that's, I think, an important contribution, again, illustrating the capabilities of LBT. So let me say some words about where we are with observing schedule for the telescope. So the pandemic, of course, had a big impact on our operations and forced the observatory to go into this, what's called the C19 or COVID-19 observing mode, which is really a service observing mode, or in some cases remote observing. But in most cases, the LBT staff are operating the instrument, and then partner observers participate through eavesdropping and manage and give direction to the sequence of observations and the way the instrument is configured. So that was required, continuing through semester 22A. And we said that in 22B, it's encouraged, but it's not required. And we have had some observers coming back to the mountain in the fall. And I think it's an ongoing discussion now about what we'll do in 23A. I think at least temporarily it's going to be similar. We'll continue to support C19 and we encourage it. But if the observers think that there is benefit to the scientific program to be on site, that's okay, and we can support that, with the caveats that have always been in place about some extra caution required in the wintertime, right? We generally discourage people from driving up and down the mountain in these periods of time when the road can be particularly hazardous, but that's something to talk about. Anyway, access to the mountain is back if people think that's important for your program. Let me give some updates on instruments. During the summer shutdown, a new G40 grading was installed in Lucy 1, and that similar grading already exists in Lucy 2. And that is intended for use specifically with AO, giving you moderately high resolution, R of about 8,000. This is not quite available yet. There's some characterization needed to understand its performance. Dave Thompson's going to be working on that and hope to have some more news in the coming months. Another interesting development is this device called Mobius. and that is an acronym, Mask-Oriented Breadboard Implementation for Unscrambling Spectra. What this is it's a optics embedded in a Lucy slit mask that introduces cross dispersers and then allows you to simultaneously get spectra in all the infrared bands with the G40 and N375 camera, giving you about 1,800 spectra. And so there's two apertures you can use for source and a simultaneous one for sky. And the science case here is for studying asteroids. So an asteroid is rotating, it may be irregular, and so if you get one bandpass and you come back later and look at a different bandpass, you're really looking at a different source, right? You're not getting the equivalent thing the whole time. And so this allows you to get simultaneously all the infrared bands, and if you use mods on the other side, you get optical through infrared all simultaneous, right? It's pretty cool concept. Dave Thompson had been kind of a prime mover in putting this together, although the science impetus came from scientists at Arizona's Lunar and Planetary Lab, who also contributed funding. So a picture of what this looks like is here, with the Lucy slit mask on the left, with the optics that are embedded in that. So it's basically light is introduced, it gets redirected and then cross dispersed and then comes back out in the same direction. And on the detector, this is what you see with the spectrum, the different band passes then offset the cross disperser. And then you have the two apertures there. So that is in thermal testing in the lab now. And Dave hopes to take it to the telescope pretty soon. And I can't say for sure when it would be released for general access, but I think it's on a good path where that won't be too long before that's available. There's only certain types of projects in science where this would be relevant, but I think it's intriguing to have the option of doing simultaneous measurements in all these bands. Okay, a few words about mods. So there's a major piece of work that's planned for that, which is an upgrade for our aging CCD controllers. And there's some technical challenges with that, but I think Mark Wagner and our staff working with Ohio State, as well as Mike Lesser at the University of Arizona Instrument Science Lab, they've made a lot of progress just very recently and are about ready to place an order. And so that would be implemented then sometime in 2023. The Pepsi high resolution spectrograph, the board has charged us with continue to work towards a full handover of this as a facility instrument. And it's a very robust instrument. It's in the sealed space with very strict environmental control for stability. And that means that it doesn't fail very often, so our engineers don't get a lot of chance to get in there and learn about it, but they are, over time, they're getting more knowledgeable about that, and we're making progress. Also, there's some questions that have come up, and we were talking about this earlier today, about the pipeline support for the data, which is being entirely managed out of Potsdam. And we're doing some investigation to understand what we can do about making that more broadly available for individual observers to access and use. Let me give a few updates on the state of adaptive optics at the observatory. The Sol upgrade, which has been in the works for a long time for single conjugate adaptive optics, that commissioning is progressing, and there's sort of a bunch of words here. The summary point is we're on track for achieving acceptance of each of these, the system at each of the 4 foci, the 2 LBTI foci, as well as the Lucy foci, within the next few months. And so the acceptance review for Lucy SX has happened. The LBTI SX commissioning is completed. We have a scheduled acceptance review in December. And then following soon after that will be LBTI DX. And probably in March is when we anticipate Lucy DX commissioning and acceptance review will be concluded. So I think that's good news. Now, it's important to understand that I think that's a very significant milestone in terms of achieving a threshold of performance and also signaling a transfer of oversight and management to the observatory. but it's clear that there's going to have to be continued work to continue ratcheting up the performance for these systems and work on enhanced robustness. And so that's going to be ongoing after these reviews are completed. Also related to AO is the state of our adaptive secondary mirrors. And there was a lot of work on these during summer shutdown. There were a number of detached magnets on the SX thin shell, which were reinstalled and glued on. And it was discovered in opening up SX that there were some vibration isolators that were falling apart basically, which was not good. And so those were replaced, and then DX was opened up as a preventive measure to replace those as well. Both units then were restored to operation on the telescope and working. And again, there's some performance aspects we're working with to make sure they function in the way we need them to do, but it's a good news story in many ways about this progress. Also related to the adaptive secondaries, there's an issue with one of the thin shells. It's the one on the SX side. And that is that it's been noted, and some of you may have noted, that the throughput has been significantly reduced. People using mods have especially noticed this. It's about a factor of 2 of reduced sensitivity. And I think it's pretty clear at this point that the cause has to do with the reflectivity of the thin shell coating. And it just needs to be recoded. So we've been talking to ADS about producing some handling equipment to allow us to safely manage that. And we're planning to work towards a recoating of this. We have a spare thin shell, which also needs coating. Do that first, and then gear up to do a coating of the one on SX during the 2023 summer shutdown, to do it during summer shutdown to minimize impact on its availability during science nights, and hopefully complete most of that process during summer shutdown so that it does not adversely impact access to the secondary. So meanwhile, we have a problem for the next semester, which is we've got a mirror on one side, which is causing us to lose a lot of photons. And so one thing we're considering is the possibility of doing block scheduling during the spring semester, so that if there's long intervals where you don't need the adaptive secondary, you can put the rigid on and get better reflectivity. And then when you need to go back to adaptive optic measurements, you put the ASM back on. So we're still evaluating whether that's going to be feasible. We'll have to look at the scheduling situation when it comes to spring semester, but that potentially helps a little bit in recovering some of the signal. Okay, moving on with a few other instrument updates. The LBT interferometer is back and performing well. It's doing fringe tracking. Recently completed some Fizeau programs just within the last week, and only programs planned in this semester. And another important milestone is this was really, in terms of AO support for this, it was entirely run by the LBTI team until recently. And we sort of transitioned that to where the observatory staff, the AO staff on the observatory as a whole are supporting that. And that's important for the other instruments that will make use of the AO focal stations at LBTI. So I think that puts us in a good position to support those instruments going forward. Link Nirvana, I think there's probably people in this audience who know more about this than I do, but we met with Tom Herbst when we were at the Max Planck Institute last week, and he and colleagues are planning to go back next month. It's been a long hiatus of about 3 years since they've had access to work with this on Sky, and so hopefully that will allow Link Nirvana to progress forward in its ability to do science. Okay, so let me talk about new instruments. And so here in Padova, I'm not sure that I should be the person presenting this because everyone here is the source of all the news, but I'll say what I know, and people should correct anything I say that's wrong. So SharkNear is a very exciting new instrument, and most people, if not everyone, is familiar with its capabilities. intended for high contrast imaging and spectroscopy in the near IR. And the science driver here is for study and detection and characterization of exoplanets with multiple observing modes. It's designed for installation at the LBTI SX focal station, and it's a collaboration across multiple partners in the LBTI consortium, LBTO consortium. Okay, well, there's been a lot of progress in the last year with SHARC-NIR. So just to give you sort of the rundown there was the preliminary acceptance Europe, which was completed successfully in April. And right after that, the LBT board met and gave their approval to move forward with installation of the instrument at the observatory, with the qualifier that permission to begin on-site commissioning is contingent upon completion of the acceptance process for the SX Sol plus LBTI focal station. So here we are with the instrument actually arriving at the mountain in June. And soon thereafter, we had our pre-commissioning 1 run, which a number of people in the audience here participated in, with just the initial sort of getting things going, unpacking, hooking things up. Yeah, so here's some happy team members in the image below. And then that work continued in a pre-commissioning 2 run in October, and installation of the instrument on the telescope. And I had the good fortune to actually be out there when they were bringing the cryostat in. You see the picture there, and start validating functionality and operability, alignment and testing, and a lot of progress was made there. Okay, so the next development is last week, the LBT board had their meeting. I was asked to report out on this and basically told you what I just did, told them what I just told you, and they reaffirmed with a resolution that the SHARC-NIR can go forward. And they said to grant SHARC-NIR access to the telescope for nighttime commissioning and scientific operations contingent upon final acceptance of Sol LBTI SX. Okay, so what about the state of Sol LBTI SX? I already told you about that. The commissioning activity was actually concluded some time ago, but the final acceptance, there is a specific date now set in mid-December for that acceptance review to take place. All indicators are it's on a positive trajectory for that to have a successful outcome. So I think we're in good shape to move forward with the nighttime commissioning nights, which are already scheduled in January. So I think it's looking very good. And a lot of people here deserve a huge amount of credit for all the effort you put into this very exciting project. Okay, so let me talk about second new instrument that's coming, the other SHARC-Viz. This is an ENAF project. It's similar in terms of doing high contrast imaging in the optical, again with the science driver around studying characterization of young exoplanets. And in the optical region, H alpha is of specific interest for tracing young systems. And this is also pushing new territory in terms of using AO to shorter wavelengths. And it's designed for installation at the LBTI DX focal station. So its status is on the similar path, but following behind SHARC-NIR. The preliminary acceptance Europe review occurred successfully in July. They had planned to take the team had planned to take this instrument. You may have heard about this, to the EOS telescope in Hawaii. That's the U.S. Department of Defense telescope on Haleakala. And unfortunately, that was canceled at the last minute by that facility for their own reasons. And so that did not take place. And as a result, it hasn't shipped anywhere yet. This is also linked to the availability of the Sol system. So in October, November, there's been DX Sol LBTI commissioning. And as for the SX side, there's now a review that's being scheduled, anticipated to be in January for the acceptance. And again, it looks very positive that will go forward. And so the board also gave its approval to ship SHARC-Viz to LBT to begin installation, and contingent on that acceptance. But that looks like we're in good shape there. And so anticipated shipment of the instrument to the telescope in the first or possibly second quarter of 2023, with pre-commissioning activities to start after that. Okay, so there is a third new instrument that's coming, and that is the iLocator high-resolution spectrograph. It's optimized for radial velocity exoplanet studies, working in the near-infrared bandpass Y and J. And it is illuminated by a distinctive aspect of this. It's illuminated by single mode fibers injected using adaptive optics, which delivers then on-sky diffraction-limited spectroscopy. The project is led out of Notre Dame University. Justin Krepp has been the PI. Jonathan Krass has been sort of the prime mover in carrying this project forward. Jonathan very recently moved to Ohio State University. He was in a soft money position at Notre Dame. And at Ohio State, he's joined the permanent instrumentation staff there. So I think that's good news in terms of ensuring some long-term support for this instrument. And we'll also have, the backing of the Ohio State instrumentation facility, which has a lot of resources. The instruments will still be owned by Notre Dame, but with strong participation also by Ohio State. And the great news is Jonathan, stayed within the LBT family, so he's here to help move us forward. So this shows a model of the spectrograph and a design of the spectrograph in the lower left corner, and the completed cryostat on the right. So the current state of this instrument is the acquisition camera and demonstration of the fiber injection system occurred several years ago. And currently the spectrograph integration is progressing with the idea that it will be finished really very soon, enabling full system integration in spring of 23. And the idea is that it would be delivered to the telescope in summer or fall of 23. So that's what I wanted to say about instruments. And I just wanted to say there's also, this is sort of not so close to what the observer sees, but important for the observatory. There's some rather significant work that's being done on other aspects of the telescope. The high pressure bearing system has needed modernization. This is what supports the telescope. And because what we have is rather antiquated in this, so there's been a significant effort on that, and it's pretty close to completion, but we've been hung up, unfortunately, by some supply chain issues with parts that have been delayed in arrival. We hope those will come in soon. The illuminization system for reilluminizing the primary mirrors, the control system is also rather antiquated, and that's sort of concerning because we can't have a failure there in the middle of an illuminization process. So there is a focused effort to modernize that starting in 2023. And another broader topic relates to vibration mitigation efforts, and there's a multi-pronged effort there to reduce vibration from various sources, including installation of a new chiller, which has already happened within the last year. A picture is shown there with various, it's lower vibration, as well as some of the couplings are designed to minimize transmission of vibration. And in other locations on the telescope, we have passive and active control measures being installed with a global analysis of the vibration budget in relation to impact on image quality being planned, led by Mark Smithright. Okay, so as a discovery machine, we're interested in getting these discoveries out and demonstrating productivity from the telescope. And a common metric for looking at that is publications. Let me say a little bit about that. This shows that these were provided by Christian Liet, who has compiled these. You may have seen these graphs in the past. And so this is cumulative publications broken down by different instruments, and it starts, of course, each curve starts when the instrument's commissioned. So the first instrument being LBC, and then others following. And the good news is all these curves are going up. It's interesting that MOVS, you can see the orange curve there has this sharper rise than some of the other instruments. It's a very productive instrument. The other thing that's, I think, is really, the other instrument that's starting to take off measurably, I think, is Pepsi, which is the red curve in the lower right. And another way to see this is in the next diagram, which is publications broken down each year. And the color coding shows the instrument. So blue is LBC, orange is MODS, and so on. And illustrating what I said before, you can see MODS has the largest of any of the instruments in terms of its contribution. Pepsi is the red bar, and you can see it's growing. And in the upper part of those bars, you can see a heavy solid line encompassing part of the bar. That represents the fraction of publications that utilize adaptive optics. And so you can see that's significant, and we expect that to grow in the future with our adaptive optics system coming into a more stable condition. The other thing that I think is great news, this is the count through October. And so if you extrapolate to the end of the year, we're on track to, I think, match and actually exceed the record count we had in 2020. So the global number of publications is continuing to rise, which I think reflects very favorably on the productivity of the observatory. And my goal is to make sure that keeps going up. So that concludes my summary, but I'm happy to answer any questions, and would be glad also to hear any feedback you want to provide about your experience with the observatory.
For the answer from okay, are there questions from the audience here? Yes, are there.
I have a question. At the moment, more than half of the LBT archive is not accessible worldwide. Do you have some plan to make all the archive completely available worldwide?
Okay, so just to repeat the question in case people had any difficulty hearing about it, it's about access to the archive and the fact that part of it is not accessible on a open basis. And this was quite actively discussed at the board meeting last week. And I have to say, I was not aware of some board policy around this, which is driving towards open access after, I believe, 1 year, and have been tasked with identifying what we need to do to move forward to provide, access according to those rules, make sure everyone's on board with that we have the processes and the mechanisms associated with the archive to enable that. So short answer is we don't have an instantaneous fix, but it has emerged very definitively as a priority, and I've been tasked to go follow up on that.
Any questions from the audience here? No, you have questions from outside? So, okay, so there is no other questions from remote. If there is any question, please raise your hand or raise your voice. Scusa?
Sì, yes. Roberto, Simone speaking. Simone Esposito from Arcetri.
Vai, Simone.
So hi, ciao Joe, very good to see you here and see the presentation and the overview. My question, you know, of course, that I'm most interested in the AO part. So my question will be about do the observatory has the resources for the hirings of, the AO lead that actually already in progress? And I don't know if you want to send another message, right now to all the people here, but if there would be finances or budget to allocate for hiring other 2 young AO scientists as we did. Of course, I don't want you to commit on anything now, but just to tell us, how you see this for the future. Thank you, Joe.
Thank you, Simone. And I want to preface this response by acknowledging the incredible contributions by Simone Esposito, Enrico Pina, and their colleagues at Archetri in terms of helping progress our adaptive optics work. It's been there's been invested a huge amount of time, and Simone and I, Mark Smithwright, meet weekly by Zoom to talk about progress, and I want to publicly acknowledge their contributions. In relation to the staffing question, one thing I didn't talk about actually was some of the things that are going on with our staff, and maybe I'll preface with those big picture comments before coming in to respond to Simone's questions. So we've had some significant changes in staff in addition to me as new director. Christian Diet is still around. He will be around at least through January, according to the pre-arranged extension of his appointment. But he's got some projects he's continuing to work on with the observatory, and so may stay on with a courtesy appointment or some special arrangements like that beyond. The other big changes, our business manager who's been with us for 10 years, Dean Gardner, is retiring, and that's quite an important position for the observatory. I'm happy to report we did a search and have found, I think, a very well-qualified person for that position. The other thing that's happened is we've lost several people out of our engineering department, and this is a conversation I'm repeating. It's a challenge I'm hearing all over the place of hiring and retaining technical talent, right? Many institutions are encountering this. And in our case, we lost 3 of our engineers moving on to the next big thing, the Giant Magellan Telescope. And they can do that without even leaving Tucson, right? Because they can just, and of course, there's a lot of technology knowledge that they can take from LBT directly over to GMT, which is why they're attracted to GMT. So in some ways, it's kind of natural. People want to progress in their careers and do new and exciting things. It challenges us. It also creates new opportunities, which Mark Smithwright and I are discussing about what we can or should do to, should we be reconfiguring our engineering staff in some ways? And that's an ongoing discussion. So there's a search in progress right now, a very important search for the AO lead at the observatory. And we're sort of in the middle of that right now. And I think we have discussed exactly what Simone was asking about, is we really want to position ourselves to be a place where we're continuing to innovate and do new things around adaptive optics. And of course, the way to do that is by having senior staff, but also some very energetic younger staff, postdocs, and things like that. And so that's something I'm interested in. I think we have to look closely at the budget, quite frankly, to see how that's going to work in terms of our staffing profile. So Simone, that's a very long answer to your question, which is I'm definitely interested in that, but I think there's still some variables related to budget. I'm not sure where that's going to land.
Thank you, Joe, for the answer.
Sure. Any other? Maybe this. Oh yes, Elizabeth.
It's a little bit early. It's a kind of joking question. Where do you see it?
Where do I see LBT in 5 years?
5 years.
5 years.
Yeah, not 50.
I see a large, in my experience, first of all, you have to know where you want to go, right? And I want to see this facility realizing its promise as the largest telescope in the world, right? Measured by total collecting area, but also by interferometric capability with its baseline, which is unique and distinctive in this period before the other ELTs come online. So I want to see us really performing at a high level to leverage those capabilities. And in my experience, a lot of progress, there's new things you can do, big things you can do. The new instruments are going to bring in some very exciting capability. But in other aspects, a lot of progress comes by many small steps, right? And there's many ways we can improve the effectiveness and success of the observatory and the board, is telling me the same thing, a more systems-oriented focus to how we do our business, keeping a strong strategic focus on the science, right, and what we need to do with the instruments in order to support that, and make sure our staff are aligned in a way consistent with that. Now, science never stops, right? We've got a generation of telescopes instruments coming on board now, and we want to make sure they're successful, but it's already time to start thinking about where are we going next. And I think connected with this is the potential that we're looking for a new partner to participate in the observatory, since Germany is planning to scale back their participation. And so that is worrisome, because they contribute an important part of our budget. But once again, it opens up interesting possibilities of maybe attracting a new partner that would want to do something new and innovative, perhaps with a new instrument at the telescope. So 5 years from now, we're going to see a high-performing facility. We're going to be leveraging some of these attributes like the LBT interferometer, which I think is on a very strong trajectory, as well as the new instruments that are coming on board to really turn out some exciting science, and that in turn feeds back to our ability to engage potential new partners.
Okay, I was just adding the but I don't want to add the discussion at the board that we should now start with the next generation instrument for LBT that will be in the landscape of the ELTs in maybe a bit more, well, okay, about 5 years.
And I think, something I'll just go ahead and sort of put out there. I think there is a strong interest in having an LBT science meeting, right, by LBT users. These have occurred in the past, but it's been a while. I think there was one plan to occur right around the time of the pandemic, which unfortunately got canceled. But I think it's time, to restore some energy and excitement in our user community, and with a forward-looking vision, right? That's where we can bring people together to generate some new ideas. So the Science Advisory Committee, working with me, has been tasked with fleshing out that scenario of having a meeting, and the details of that remain to be worked out. I don't know when that would be, but we're looking at the next perhaps year and a half might be the time frame when that would take place. So I hope you all come when we advertise that. So.
Any other question from the audience and from remote? No? Okay, so thanks again, Joe, for being here for your work. And thanks for the numerous participants from the net. Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.